Hello everybody, my name is Dan and I'm here to talk about introductory set theory. Now what is set theory? Set theory is the perspective study in mathematics of sets. Now what are sets? Sets are mathematical objects that contain and have the property of being just simply a collection of items. There's no notion of finite or infinite, and the definition is strictly vague. So the idea of a set is very simple and very concrete. You can think of it sort of like a box. So suppose I drew a box. Suppose we had a set S. We'll just label it as S and think of it as a box. We'll just put a box here and have a suffix down here of S. So this is a set. Likewise, here's a set up here. There's two rules of all sets. The first being that this set S cannot contain duplicates. So no duplicates. So not to confuse this with the concept of a multiset. A multiset can contain duplicate elements. For example, if I wanted two twos, or I wanted two people that are identical to each other, that would be allowed in a multiset. Otherwise, it would be automatically generated into a single element. Likewise, another rule here is that the order does not matter. This one's very important. This is to separate the notion of something called an n-ordered tuple, or just an ordered tuple, and a set. A set has no order. So we'll denote, much like we have up here, S. This will be using these parentheses or brace notation, and all the elements will go one after the other in the notions with a comma separating them. For example, if I had 1, 2, and 3, these are all elements inside of S. So for all elements inside of S, they all have the property where 1 is an element of S, and this means in. So 1 is in S, or 2 is in S. 4 wouldn't be in S. So that would be how you'd note this notation right here. So we're talking about things being in the set, and this is just an object. So the number 1 is just a mathematical object. Numbers are just mathematical objects. So the idea of putting things together in terms of some sort of idea, such as here, is something that we'd use for sets. So likewise, if we had this up here, we would have 1, 2, and 3 inside the box. So there's your set right there. So you think of it like a box. But the box has two properties. There's no duplicate, so if I put another 3 in here, or likewise up here, these are both sets. But the thing is, how many elements would be in this set? 3, not 4, because there's 1, 2, 3. And keep in mind, that's a duplicate. And likewise, the order doesn't matter. I could just shuffle these two right here. Suppose I didn't want this 2 and this 3 right here. I want 3 here and I want 2 here. So in terms of notation, doesn't matter the order. Likewise, if it was just a box and I just put a bunch of things in it, doesn't matter the order. So that's very important notion. So set S. What kind of operations can I do with sets? Now sets have a lot of fundamental operations with them, but we'll only cover a couple of them. So just to hammer this in one more time, I'm just going to suppose a set. I'm just going to have Bob, some strings. I'm just going to put Bob, cat, and hat in a set. This is equivalent as a set to Bob, hat, cat. Now, these two sets are equivalent to each other. There's Bob, a cat, and a hat in there. Likewise here, there's a Bob, there's a hat, there's a cat. Now keep in mind, repetition of elements doesn't matter. They're just counted as one element. So really, you can, in terms of notation's sake, you can just remove that and rewrite any of these in any arrangement or permutation of the other one. That's why they're equivalent to each other. So, with this idea of a set, let's cover some basic operations, very basic operations. And they'll come in turn if you're very fond of arithmetic and things that you may be familiar with. With this in mind, let's talk about some operations. Let's talk about union. Then we'll talk about intersection. And we'll talk about set subtraction, or sometimes called setting exclusion. We'll call it set subtraction here. So we'll talk about these three operations. And keep in mind that set theory and logic have a lot of relationships with each other, and fundamentally they're almost identical. It's just one sometimes uses different axiom systems, and one is more formal system based. But in reality, they have one-to-one correspondence in a lot of proofs and theorems. So be careful. So first I'm going to talk about union. Union is denoted as, if I had two sets, A and B, suppose sets A and B, then the union is A union B, where U right here is the union operator. Now I'm just going to pull out some things and do an example. The union is where you take all the elements and you place them into one box or one set. You don't care about duplicates, you don't care about the ordering. You just care about the fact that you're putting these two sets together. And it can be relatively tricky if you don't know some properties. Like some properties of sets involve disjoint sets or non-disjoint sets. But we won't talk about those here. A union B is simply the notion of putting two sets together. And not to be confused with addition. Addition is fundamentally operating on numbers. This is far more general. In fact, you can terms and note addition in terms of natural numbers and union operations. One-to-one. But you have to take the cardinalities or the size of these sets. Otherwise known, if you wanted to know the cardinality notation, the cardinality of a set is the absolute values, if you're not used to that notation. That's the cardinality. So, let's do a quick example here. A union B. Suppose we have A is equal to 1, 3, 4, and B is equal to 2, 1. 2, 1. So this one only has 2 elements, that one has 3. I'm going to do A union B. So A union B. Now what is A union B? You take all the elements that are common, you just ignore them by just simply writing them down again, and you take all the ones that are in common and not in common. So simply you just put down, okay, notice here's 1 here, there's a 1 there, so there's 1. 2's not in there, so just write down 2. Not in here, but you're just going to put these sets together. So A union B is 1, 2, 3, 4, or 2, 1, 3, 4, and all the permutations possible between these 4 elements. So that's union. It's very simple. Now we're going to go to the opposite, or whatever terms you'd like. They have a high relationship. It's called the intersection. Now the intersection is the other idea. Instead of putting things together, you try to take everything that is common between the sets. So notice I wrote down all the ones that are even common between the two. The idea of the intersection is that you take all the elements that are not in common with each other. Okay, let's get to an example of intersection. Intersection is denoted as a cup instead of a U, or a bowl. So A intersection B, where A is 1, 2, and 5, and B is just 5. What the idea of intersection is, you take the intersection between here and there. So you look for all the common elements, and your output is simply all the elements that are common between the two sets. It's relatively simple, but a little bit more complex in terms of operations. Notice, okay, which element here doesn't match? well, those two are definitely in there, but 5 is between the two, so you would just write down 5 in its own set, because the output of these operations are sets. Not to be confused with arithmetic operations. These are all binary relationships, but they're using sets. Next, intersection, union, they have a lot of relationships with each other. We don't have enough time to go through those right now, but we can definitely talk about them another time. So next we're going to talk about set difference. Now set difference is relatively, it's more of what you'd consider something subtraction-like. So I'm going to suppose there's a set A, and it has 1, 3 inside of it, and B is going to have 3 in it. Now, there's several notations for set subtraction. I'm just going to use the one I'm more familiar with and the one I think is much better. So I'm going to use it. So A, set subtraction, B. Otherwise, sometimes people like using the subtraction sign, but it does confuse with the arithmetic operator. So it says slash right here. So A, set subtraction, B, is the idea that you take everything that's in the left operand and you compare it against the rightmost operand. You remove all the elements that are inside of this operation for which the ones that are common. So for example, if there's nothing between here and there, like if I took the intersection of that, and if it was nothing, like there's nothing in common between the two, then set subtraction is not going to really do anything. Because like there's nothing to take away from set A if B was, say, 5 instead of 1, 3. So for this operation, it would be A set subtraction B, where that would just be 1, because the set subtraction would take away the 3, because 3 is common between the two sets. So in terms, really, this is a lot like intersection. Intersection otherwise would just take all the common elements. Here, what happens is you take away all the common elements from this leftmost set using all the ones that are in the rightmost set. So in reality, it's very related to intersection. So with that in mind, we talked about these main operations. Now these are the 3 most common operations in set theory using sets. But we need to bring in another concept. I mentioned this idea of nothing, so we need to make this much more concrete with the idea of an empty set. So empty set is often denoted as this symbol right here, the empty set. So if there's, say, I'm just going to give a good example. Suppose we have A intersection B, just for arbitrary sake. Suppose that this one has absolutely no common elements with that set, which is otherwise called disjoint sets, or the disjoint property. If I take A intersection B, it should outcome the empty set. Empty set is sometimes noted also as just literally a set with no elements in it. So don't be confused if you see a set that has absolutely nothing, that's really just the empty set. So ideally, that these are the basic notions of set theory. And hopefully you learned something new, and thank you very much for watching, and have yourself a beautiful day.